So yes, I'm Rose Pearson. I would like to say thank you very much for the opportunity to speak on behalf of myself and my colleague Eugen Niculae. So today I'll be talking about my study, which is the analysis of the vertical movement of active GNSS stations as a result of semidiurnal tides. So a bit of background research on the topic. So Ireland, here where I'm from, experiences a lot of semidiurnal tides exceeding 5 meters. So as a result of this, it was a cause for concern to see is vertical land motion significant along the coast as a result of these tides. So this kind of came about as a result of another study I'd read about where post-glacial rebound was affecting the movement of land in Canada. So therefore I applied this to an Irish example and used satellite technology to monitor this. This could be of interest with relation to remote sensing to do with flood mapping to see if there is an extreme flood coming, an increased water level, would this affect the land level nearby if a monitoring study was going on. So the study duration for this was 1 year long, and I picked 3 different locations. So just the main aims of my study was to determine whether or not there was an influence on coastal vertical positions, and then if there was an influence there, to what effect was this here? Would it be a cause for concern for monitoring surveys along the coast? I also wanted to determine if there were trends present. So as there are semidiurnal tides, so 2 large and 2 high tides and 2 low tides every day, is there a cyclical trend present, and is there a trend present throughout the year? And I also wanted to discern which method of GNSS processing, so precise point positioning or a manual network adjustment, would best identify this motion that is happening along the coast. So my methodology, I had to identify 3 stations. I picked 3 along the west coast. So the west coast was chosen as it has a larger fetch, and it also is quite a jagged coast. So there's a lot of kind of ocean tide loading going on along the coast, so this location was best. So I selected Sligo, Galway and Fenit to get a good western distribution along the coast. The 21st of each month was selected throughout 2020. I had a look at new moon and full moon charts to try get the most celestial prominence to see when the largest and minimum tides would occur, and the 21st averaged this out nicely. So next I had to identify active GNSS stations in close proximity to these tide gauges in order to capture data. So unfortunately, there is no coincident stations of a GNSS station and a tide gauge. So I picked ones closest to it. So as you can see, the distances down the bottom here, none of them exceeded 15 kilometers from them, which meant that no tidal coefficient had to be applied for this delay, this distance from the coast. This data I could capture from the Ordnance Survey Ireland, which are our national mapping agency. They run the network of the CORS network, is what we call it, continuously operating reference stations, where the data is free to download from the website in Gnsx format. So I downloaded 24 hours data from each day in study. Then to process the data, I worked with tidal predictions. So tidal predictions are approximated values to the water level at each tide gauge. So from this, I was able to figure out the highest tide and lowest tide of the day from the semidiurnal tides, and then from that create a 6-hour window around these occurrences. The 6 hours I found kind of gave the best overall high tide to low tide reading, and really showed the tide coming in and tide going out. So to correlate this with the GNSS data, I downloaded the data and then used WinTech Editor, which is a application which allows you to merge the 6 individual Gnsx files for each hour into one single file, which I could then submit to the CSRS PPP service, which is the Canadian Spatial Reference System. I chose this PPP service. There's multiple ones out there, as previous studies found this to be quite a reliable one with high levels of accuracy. It's also free, and return values are within 24 hours of submitting a file. So here's an example of the submission page to the CSRS PPP. So I selected the ITRF reference frame to receive the files back through. And this would allow me to then convert these to Irish transverse Mercator, which is the coordinate system which we use in Ireland, which is based on the ETRF. So this would allow interoperability between these two coordinate systems. The option was there to include a ocean tide loading file, but we didn't do this as we didn't want the effects to be averaged out. We wanted to see exactly what was happening there. And the results were returned via email within 24 hours. So then to the GNSS networking method of data processing was Trimble Business Center was used. So for this, I processed the vectors, provided my 3 stations along the coast, and then also picked a GNSS station in the center of the country, which would have no effects of semidiurnal tides. And I fixed this in 2D and elevations, and then allowed the other 3 stations to float around, giving me the movement due to the tides. I also applied the IGS final orbit solutions to improve the accuracy of these coordinates. So the analysis that was carried out was a regression learner, curve fitting, autocorrelation, and partial autocorrelation functions, and distribution fittings. So I'll just talk you through each one of the results here. I've summarized the results essentially. So say, for example, here I'm showing you Galway at low tide as it goes on. So the results here from Galway GNSS at low tide for the regression learner. The regression learner has allowed me to identify which model best fits the data. The regression learner was chosen as the data type was unknown and therefore the model was unknown. So this has allowed me to trial and error, essentially figure out which way is best. This was ran through MATLAB, which is an online desktop statistical analysis software. So the results here from Galway at low tide produced a R-square value of 0.4 and the root mean square error value as shown on screen. Excuse me. So observed versus predicted values follow the line fairly acceptably with R-square of 0.4 showing roughly 40% fit. The residual values are moderately random. They're equally distributed, but no trend is really present here to show that this particular model is a good fit. The model here that is fitted to this data is a Gaussian process regression model. And then with the response plot, there's no consistency really, and the true values versus predicted values have a large variation. This type of trend was seen across the data, showing that even the best fit very poorly modeled data for as a result of semidiurnal tides. So curve fitting was next carried out, and the curve fitting was carried out to identify if there were any trends, seasonal trends or cyclical trends in the data. So a sine wave was firstly trialed out on the data as a study by Brown and Eugen was carried out due to the post-glacial rebound, as previously mentioned, and a sine wave best fitted the model. The R-square value here was quite low, so then I tried a Fourier wave as it had both sine and cosine values in it, with a slightly improved R-square and adjusted R-square value. The adjusted R-square value takes in the number of predictors. So the Fourier wave best represented here Galway at high tide and was similarly carried out amongst the rest of the data at low and high tide. And again, Fourier best fitted the data. Next, autocorrelation and partial autocorrelation functions were carried out. The autocorrelation discerns if there is a direct or indirect dependence is present between observed observations recorded at any prior point. So to see if there's any combination of previously occurring influence on future data. Partial autocorrelation, on the other hand, just discerns whether if there is a direct influence between the consecutive values. So the autocorrelation values are shown as the red dots on the bar there, and if they cross the critical bounds, the blue lines shown across the stream, then it is of statistical significance. So you can see in the partial autocorrelation plot there is a spike at position 6, which interestingly enough was seen across all 3 locations in both high and low tide. So this is cause of interest and could be further looked into as well. So distribution fitting then was carried out, excuse me, and this was in order to figure out which best fit, what was the best fit for the data. So the script here was carried out, sample size of 12 to correlate with 12 months. Values A and B were achieved from the fitMeThis command, which was carried out in MATLAB also. And this allowed me to compare the AIC values, the Arcane Information Criterion. And from this, it is the lowest scoring AIC value, which will tell you the best fit. So this was carried out across 19 different distributions. And from this, the uniform distribution type was found to best all three locations at high and low tide. I also carried out a hypothesis testing at 5% confidence interval to check to see was this uniform distribution best, and in all cases it was. So the data in three locations for high and low tide was best fitted as uniformly. Finally then, I just wanted to compare the results from PPP processing to GNSS manual network adjustment. So my hypothesis on this was, at high tide, there will be an increased water volume along the coast and therefore increased pressure, so the land will decrease. So hypothetically speaking, heights along the coast should be lower than the stated GNSS value at high tide and then higher at low tide if the Earth behaves elastically as we presume it would. So the static value, the orange line shown here on the chart, was taken from the OSI from their GNSS core station values. There was a bit of discrepancy here, the limitation being that the OSI don't publish how these values were calculated. I don't know over what time period or whether they took tidal influence into account. So as you can see here, Galway at high tide, taken for example, follows the hypothesis which we expect it would, where that at high tide there will be increased water volume and therefore the values will be lower. For both PPP and TBC, this was achieved mostly. Then at a variance to this, Galway at low tide didn't agree with this behaviour and also received lower readings than the stated value. Similar results were shown across most data except Tralee, for example, which followed the hypothesis fairly well. It is also interesting to note the variances between PPP and Trimble Business Centre values. There's no real major consistency between the differences between the values, which leads the study to be slightly inconclusive into which data method is best. So just to kind of round up my conclusions there, no regression model could accurately reflect the GNSS data, as shown by the graphs below. The best fit model represented the data very poorly. The Fourier model was found to best represent the data in terms of trends, but this was hindered, as I mentioned, by the study length, as it was only over a year, and a longer period would be better to figure out the cyclical trends more specifically. There was no autocorrelation found in the data, and mostly there was partial autocorrelation found, specifically at that spike in position 6 that I had noted, which would be June, the month of June, there was a trend. All the data sets adhered to a uniform distribution as shown earlier, and then PPP versus network adjusting comparisons were inconclusive. So we're just reverting back to the aims, which I previously mentioned. There is noted to be an influence of coastal vertical positions. An exact influence we cannot say, as results were lower than the stated value, but again, another cause for further studies. A definitive magnitude could not be drawn from the PPP and network adjusted differences, and the trend which best fitted the model was the Fourier model. So future improvements on this would be to increase the study length over a number of years, collecting data and doing similar analysis, and also would be to select further sites around Ireland to get a better sense of how the tides affect different locations depending on size of fetch and other examples. So I'd just like to say thank you very much for your attention again, and thank you on behalf of myself and Eugen Niculae. Thank you very much for listening.